Now let's continue. We're going to wrap up the conservation of matter topic by discussing reaction conversions, also known as stoichiometry. So in the last set of slides, we discussed mole ratios. Now we're going to expand on that idea and show how mole ratios can be used to compare parts of a reaction. So the first idea is that a reactant could be used to predict. Okay, so it's used to predict the number of moles of a product that will form. Now, if we begin with 4 aluminums combining with 3 oxygens, these come together to form 2 aluminum oxides. What we can do is we can predict how many moles a product could form based on a certain number of moles we begin with. So an example might be, let's say there were 8 moles of aluminum to start with, and we're trying to discover how many moles of aluminum oxide would be produced. We can take our 8 moles of aluminum. We're going to use a mole ratio to compare moles of aluminum to moles of aluminum oxide. Since I begin with moles of aluminum, we're going to write the 4 moles of aluminum. So 4 moles of aluminum compared to 2 moles of aluminum oxide. The moles of aluminum will cancel. You're going to take 8 times 2, divide 4, or you can see that these reduce to 1/2. 8 divide 2 shows there will be 4 moles of aluminum oxide that form. Now, let me go ahead and erase some of that. So now, if a specific amount of a product is needed, so this time instead of knowing what we start with, we know what we want to finish with, you can also use a mole ratio to convert that. So what we'll do is we'll say that, let's say we needed to find 10 moles of aluminum oxide. Okay, so our goal is to produce this much. We'll look again at our reaction and see we've got a 2 mole aluminum oxide figure here. Now, what I would want to do is determine how much of each reactant do we need. So the first conversion is going to find the aluminum needed. What we'll do there is take our moles of Al2O3, 2 moles Al2O3 on the bottom to cancel, and then 4 moles of aluminum on top. This allows us to see 10 times 4 is 40, divided by 2 is 20 moles of aluminum are going to be needed. These are the moles required. So before we have 4 moles that form, these are the moles that we need, they're required. Now we'll also look at the other reactant. We begin again with 10 moles of aluminum oxide. Our conversion factor will have our 2 moles of aluminum oxide. But instead of aluminum, we'll look at the other reactant here, our oxygen. And we have, instead of 4 moles of aluminum, we have 3 moles of oxygen. So when we do the math here, we have 10 times 3 is 30, divided by 2 gives you 15 moles of oxygen required. So the last thing that we can do is we can compare relative amounts of reactants to each other. If we wanted to figure out how much of each reactant is necessary for a complete reaction. So I'll say that we're starting here with 12 moles of oxygen. What I'd like to do is figure out, in order for all 12 moles of oxygen to react, how many moles of aluminum must react. So I'm going to want to cancel moles of oxygen on the bottom, and according to the reaction, it is 3 moles of oxygen for every 4 moles of aluminum, my other reactant. Now my moles of oxygen will cancel. I'll be left with moles of aluminum, and if you just do the math, 12 times 4 and divide 3. You're going to see that is 48. 48 divide 3. Oh, simple math. What is that? Is that 16? Yeah, I think it is. So that'll be 16 moles of aluminum. So now that you've seen the idea, I'll give you a second to pause this, and then we'll run through the practice problems. Make sure that you're getting these right. So first off, convert using the following reaction. We have, again, our methane reaction, or not methane, our propane reaction. We have 3 moles of C3H8. We want to know how much CO2 does this produce. So we'll begin with our 3 moles C3H8. I'm going to set up my mole ratio with moles of C3H8 here on the bottom, and I want to find moles of CO2, so I'll write moles of CO2 on top. And now we'll use the mole ratio that we find by looking at coefficients. So I have 1 C3H8, I'll write that coefficient here, and I have 3 moles of CO2, so I'll write that there. We find that 3 times 3 divided by 1 gives us 9 moles of CO2. Now 8 moles of H2O are formed when how many moles of C3H8 are going to be reacted? So we're working backwards now. Moles of H2O, the product, is what has formed, and we're determining how much of our propane was required. So we'll take our 8.0 moles of water. We want to cancel moles of water and find moles of C3H8. So we compare 4 moles of water to 1 C3H8, and that's going to equal 8 times 1 divided by 4 gives us 2, so there are 2.0 moles of C3H8. Next, how many moles of O2 are required to completely react with 0.5 moles of C3H8? So the value that I know is moles of C3H8. We'll begin there. 0.500 moles of C3H8. I'll set that up with a mole ratio to cancel moles C3H8 on bottom. And I'm looking for moles of oxygen. So that would be moles of O2 on top. Looking at our 2 coefficients, we have 1 to 5, 1 to 5. Do the math on this, and we find that 0.5 times 5 divided by 1 gives you 2.50 moles of C3H8 would be required to react with, oh, it's not C3H8, was it? We just found not moles of C3H8, but let's look here, it's moles of oxygen. Sorry about that, moles of oxygen. Now 3 moles of C3H8 will form how many grams of H2O? So now I'm asking you to combine a couple ideas. We're going to use the mole ratio concept as well as the molar mass idea. So we're going to start with 3 moles of C3H8. We'd like to cancel moles of C3H8, and we're going to find first moles of water. When we look at our coefficients, we see 1 mole of C3H8 is going to react to produce 4 moles of H2O. Once I have this conversion set, I now have moles of water, but I'm going to need to use the molar mass of water to cancel moles of water and go into grams of water. So if you recall, hydrogen, 1.01, oxygen is 16, it's approximately 18. So we have 18 grams of water to 1 mole of water. Now we will multiply these across. 3 times 4 gives 12, and then 12 times 18. Yeah, the mental math isn't working all that quickly. Let's see here. 10 times 18 is 180. And 2 times 18 is 36, so 182. I believe that is 216. So 216 grams of water would be formed. How many grams of O2 are going to be required to form 9 moles of CO2? So we're doing the same thing now, combining concepts. 9.0 moles CO2. We'd like to cancel moles of CO2, and the end goal is grams of oxygen. But first we must get into moles of oxygen with our mole ratio. So we have 3 moles CO2 based on the coefficient and 5 moles of oxygen. Now that I have that, I want to cancel moles of oxygen to find grams of oxygen. 1 mole, if oxygen is a 16, we multiply it by 2 to give 32 grams. And we're going to take our 9 times 5, divide 3, and let me go ahead and do this real quick. I know, I should have estimated a simpler example, but that's okay. We're taking 9, multiply by 5, divide out 3, and multiply 32. This gives us 480 grams of oxygen.